We're going to talk about exponent rules, and we'll also talk about scientific notation. So first thing we're going to look at is the product rule for exponents. And that means that if we have two of the same values of a being raised to two different exponents, we can add those exponents together. The other one is the zero exponent. Anything raised to the zero power will be equal to 1. And that's, of course, if that something is not 0. And then we'll have the quotient rule, and that's where if it's, again, the same value but being raised to different ones, but it's division, we will subtract the exponents. For negative exponents, we will push it down into the bottom of the fraction or the denominator so that it will become positive. And then we'll look at scientific notation when we get to that. So let's go look at our exponent rules. The first one we'll look at is the product rule. So if we have 2 squared times 2 to the 5th, we can rewrite that as 2 to the 2 plus 5, which equals 2 to the 7th. On all of these, we're not going to find the actual value. We're just looking at the exponent rules. All right, so this would be like part A. Part B, we'd have x to the 7th times x cubed. And so, again, the x's are the same, so we can add the exponents of 7 plus 3 and get x to the 10th. And then if we have y times y squared times y to the 4th, we have 3 terms, but we can still just add the exponents. This is going to be a y to the 1 plus a y to the 2 plus 4. So 1 plus 2 is 3. 3 plus 4 is 7. All right, let's look at example 2. So our first one is 3x to the 6th times 5x. So here we are looking to simplify all of these here. So we can take the 3 times 5. 3 times 5 will get us 15, and then x to the 6th plus 1. So that'll get us 15x to the 7th. All right, let's look at part B. If we have negative 2x to the 3rd p squared times 4x p to the 10. So again, we'll multiply the two numbers. Negative 2 times 4 will get us negative 8. And then it'll be x to the 3 plus 1 and p to the 2 plus 10. This will be negative 8 x to the 4 p to the 12. And I guess I should box so you really know that that's the final answer. All right, let's look at another example. This will be example 3. So if we look at the first one, we have 7 to the 0 power. Well, anything to that 0 is going to be equal to 1. Negative 7 to the 0 is only on the 7, so the negative sticks, and 7 to the 0 is 1, so it'll be negative 1. However, if it's in parentheses, the whole thing is raised to the 0 power, and it'll be positive 1, because the negative is part of the exponent part. We can have something that looks like 2x plus 5 to the 0, and that'll be equal to 1. The whole thing is raised to the 0, so it's just 1. And then we can have something that looks like this. Well, the only thing being raised to the power is the x, so the 2 is sticking. And then x to the 0 is 1, so 2 times 1 will get you 2. All right, let's look at some more exponents. So example 4, we're going to have x to the 7 over x to the 4. So on this, we're going to do some subtraction because they're in a fraction. So this will be x to the 7 minus 4, because when it comes up, so think about it when it crosses the fraction line. When it crosses the line, it'll change its sign. So this will be x to the third, and that'll be your answer right there. The second one, if we have 5 to the 8 divided by 5 squared, that'll be 5 to the 8 minus 2, which will be 5 to the 6th. All right, let's go. So if we have another example of 20x to the 6th over 4x to the 5th. So 20 divided by 4 will get us 5, and we'll move our x's up. This will be x to the 6th minus 5. So this will be 5 to x to the 1 power. We just won't write the 1. We'll just leave it as 5x. And then we have 12y to the 10, z to the 7, over 14y to the 8th, z to the 7. Well, 12 over 14, they both divide by 2. We'll have 6 over 7 left. We'll have y to the 10 minus 8 and z to the 7 minus 7. So this will get us 6 over 7. Y to the 10 minus 8 is 2, and z to the 7 minus 7, that's z to the 0, which is equal to 1. So it won't stick. And I can write that out just so you can see it. We'll end up with 6y squared over 7. That would be your final answer, because z to the 0 is equal to 1. All right, let's look at example 5. So if we have 5 to the negative 2, we can put it underneath the fraction in the denominator, and it will become 5 squared. That negative exponent will become a positive, and this can be 1 over 25. So we're going to take these numbers here and actually take them all the way. All right, so as far as simplifying, if we have negative 4 to the negative 4th power, this will be 1 over negative 4 to the positive 4. The only thing that changes, the only sign that changes, is the outside exponent. It will become positive. The negative on the number stays the same. Well, negative 4 to the 4th is going to be 1 over 256. So that would be your final answer. For part C, if we have 2x to the negative 3, the 2 is fine, so it'll stay on the top, but the negative 3 needs to go down into the denominator, so it'll be over x cubed, and that would be your final answer. Now, if we have the whole thing raised to the negative 1, now this is different than this one. This one, the 2 was on the outside. It had nothing to do with the exponent. This time, the whole thing is. So it'll be 1 over 3x to the first, so that's just going to be 3x. If we have m to the 5th over m to the 15th, now on this is where you can do it a couple of ways. You can always bring everything to the top, and then if it's negative, push it back down. I like to not do as many steps if I don't have to. So I look at these two exponents. They're both positive right now, but I got to combine them together. The 15 is a bigger positive number. So if I take the 15 up, I'll get a negative value because I'll have a negative 15, and then I have to turn around and put it back down. So I like to look at them and decide where is my letter going to end up on to be positive, because you have to write them with positive exponents. So if you notice, all of these we're writing with positive exponents. So since we're looking at 15 is bigger, I'm going to subtract the 5 from the 15. So they're going to end up down in the denominator. So I'm going to have m to the 15 minus 5. You have to write the 1 on top just like we have before because nothing's left up there. And this will be equal to 1 over m to the 10th power. Now, like I said, you could have brought up the 15 and subtracted it and gotten m to the negative 10 and then turn around and push it down. You can do it either way, but I prefer just to figure out where they're going to go. All right, let's look at F. If we have 3 to the third over 3 to the sixth, again, there's more of them in the denominator, and they're both positive, so I'm going to bring down the 3 exponents. So it'll be 3 to the 6 minus 3, which will be 1 over 3 to the third, and 3 to the third will get us 27. All right, if we have 1 over t to the negative 5, well, this is kind of going the opposite way. I still want to write it with the positive exponent. So here, this has to come up to the top. So it'll be t to the 5th would be your final answer. You're going to move it one way or the other. Whichever way will get you the positive exponent. All right, so here again, we're writing with positive exponents. We are on example 6. So we have x to the negative 9 over x squared. So again, you could bring the 2 up, and then you're subtracting it, getting a negative, and having to move it down. Or I can just see that the 9 are going to have to come down here to give me a positive exponent. So x to the 2 plus 9 will get us 1 over x to the 11th. And you're done. For part B, we have 5p to the 4 over p to the negative 3. So here I need to move these up so that they become positive. So we'll have 5p to the 4 plus 3. And if you notice, as I'm moving these, the sign changes, because when they cross that fraction line, we're changing their exponent sign. So here it was subtraction and becomes addition. Here it's subtraction, it becomes addition. All right, and there's nothing left in our denominator, so this becomes 5p to the 7. All right, what if we have 2x to the negative 7y squared over 10xy to the negative 5? All right, so the number 2 over 10, they both divide by 2, so we'll end up with 1 over 5. And at this point, we're going to put the 1 because we don't know what will land up there. Now between the x's, are they going to stay at the top or are they going to move down? Because they need to be positive exponents. So they're going to go in the denominator because this will be positive. We'll move that negative 7 down and it'll become positive 7. So 1 plus 7. My y's are positive here and negative here, so they're going to have to go up to become positive. So y to the 2 plus 5. So that'll get us 1 over 5, y to the 7, x to the 8. Now you don't have to write the 1 there because we do have a value up there of y to the 7th. If everything ends up in the denominator, make sure you put a 1 there. Don't leave it empty because otherwise it won't be right. You want to have the right answer. Okay, so the next thing we're going to learn is scientific notation. So for scientific notation, we are looking at a times 10 to the r. You have to move the decimal, whatever the number is, until the new number has a value between 1 and 10. So it's either equal to or greater than 1, greater than or equal to 1, or less than 10, but it won't equal to 10. So it has to be a single-digit number in the front. We'll count the number of decimal places. The decimal point was moved in this first step, and then if the original number was 10 or greater, then it's going to count as a positive exponent. If the original number was less than 1, we'll count it as a negative. And then the product, we'll put those two steps together and get something that looks like this. All righty, so this is scientific notation. So here is example 7, part A. If we're given 7, 3, 0, and 3 zeros. So 730,000 is our number here. What we want to do is write this so that it's between a 1 and a 10, but not equal to a 10. So we need to get our decimal place right there. Now realize that our decimal is way back here because we have 730,000. So what we're going to do is count how many places it takes to get that there. So I usually do little loops. There's 1, 2, 3, 4, 5 places it took to move the decimal from here clear over to here. So that means our number will be 7.3 times 10 to the positive 5. Because it was a bigger than 10 number, it's a positive exponent. All right, let's look at another option. If we have 0.000000104. So this is a really small number. So again, we have to get our decimal behind that first number that's not a 0. And so we're moving the decimal this way. 1, 2, 3, 4, 5, 6 places. So that means we'll have 1.04, so we put all those numbers there, times 10 to the negative 6. On here, we didn't put all those zeros because there's no number after it. Here we'll put this 0 because there's another number besides 0 after it. Alrighty. The other way that we can do our numbers is standard notation. So basically that is taking our scientific notation and going backwards. So if we look at example 8, if we're given a number of 7.7 times 10 to the 8th, that means because it was a positive number, it's going to be a bigger number. So we've got to move our decimal places all the way back. So I'm going to rewrite my 7.7 and understand that that decimal place right there has to move over 8 places. So 1, let me use the red. 1, 2, 3, 4, 5, 6, 7, 8. So what that's going to do is fill in 7 zeros. So now I'm going to rewrite it as 7, 7, and it'll have 7 zeros. 4, 5, 6, 7. So it's a really, really big number. Let's look at part B. If we have 1.025 times 10 to the negative 3, if I rewrite my number of 1.025, that negative tells me that it needs to be a smaller number. So the decimal has to move this way to make it back into a smaller number. So my decimal place is here. It's got to go 1, 2, 3. So I'm going to have 2 zeros right there with my decimal point right here. So my new number will be 0.001025. And I like to put the 0 in front, but you don't have to on that there. So this would be your final answer here, and this would be your final answer there. Don't answer with leaving all the loops if we're looking at preparing for an exam. And these would be your answers on here. And that's scientific and standard notation.